Yes. The second thing that we need to talk about, it's about the stationarity. Yeah, the stationarity um, plus weekly dependency, stationarity, and it's very essential for our analysis. As you remember that we for the type of data we do have factual data, uh, anything that is not changing, plus we do have time series, cross section, or even also panel, and this econometrics is mainly focusing on the time series. So we need to check whether during the information, the observation that we are collecting on daily basis, whether it's stationary. So I'm a bit assuming that I'm starting with my XT. This is an observation. It's what is realized. It's what it is realized. It's a realization, actually. And essentially, alongside when we look at the time period is changing from x1, x2 up to xt, a biggest number that is possible in our observation. And we assume that we take it into account that the xt, our xt is also a stochastic. It's a stochastic. It's a stochastic. It's something that is observed randomly and it's being realized. So today's weather or today's stock prices can change. Uh, and we say it's an actual as long as the day has already done. But we can predict, but our prediction can be different from the what we realize. More to the points when we look at the beta, so the beta LS or the beta sample, as long as we are increasing the sample size, so it may make us to tend to the beta parameter. And the first assumption that's to confirm that our this series, or the observation that is changing alongside the time, to confirm that it is stationary, the first assumption should be that the expected xt is equal to the parameter, and it should be different from the change in time. I'm assuming that I'm getting something, but its mean is not changing. It's not relating to the time. It's not changing. It's not acting to the time. There is a difference between time. So as long as the time is changing, but the mean is remaining stable, so a parameter mu. That is the first concept. Uh, and eventually, when we look at its variance, like the second one, the variance, it should be having a variance of xt should be equal to a sigma, a constant, but different from, let me just write it, my equal sign to be shorter, but different to a function of time t. And conversely, for the third one, the covariance of my xt, or the correlation of my xt, today's xt, versus the xt's of tomorrow, because it's t plus h, should be a given function of h, but different. It should be a constant, but different in times. It should be not be a function of time. What does it mean? It means that when we are looking at the information here, the correlation, the correlation of my xt of regarding to xt plus h should, as long as it should be tending to 0 when my h is tending to the infinite. So as long as I'm moving from x1, essentially, as long as I'm moving to x1 to xt, I should have a correlation which is equal to 0. So which means as the way the observation is increasing, or the observation is being realized as a stochastic, it should be the correlation among those variables, those observations alongside the time, it should be equal to 0. There should not be any correlation, which means that my hn is tending to the infinite. Thank you.